Okay, so the only thing I want to remind you of today, and I don't want to, we'll come back to this, but the system, to solve a system of equations, I'm trying to find the values of all the variables that work in each equation, right? So I want to find, there are an infinite number of solutions to the top equation. You pick an x, I'll give you a y, right?
Yeah.
Does that make sense? There are an infinite number of solutions to the bottom equation. Each of them is an ordered pair that corresponds to a point on that line. You give me an x once again, and I'll calculate a y from that, or you could, right? But what we're looking for here is the single set of values, or maybe more, right? We want all the sets of values of x and y that satisfy both equations at the same time, right? And so today's thinking is, okay, we're not going to go about finding those shared values of x and y, that shared solution analytically. We're going to find it graphically. What does that amount to graphically, of course? If we're trying to find the value or values of x and y that satisfy both equations, ordered pair is a point, right? What am I looking for? Intersections, yeah, right?
Wait,
Yeah.
so couldn't you just graph it like we were and then
Exactly.
just press intercept?
Exactly, that's what I'm going for.
Oh.
We could just put these into the calculator and do intersect, right? So if I go into the calculator, now you can use the fancy fraction template, that's fine. I honestly think that maybe it even takes a little longer to do though. If you're really trying to get these answers fast, you could just, like, I don't need the fraction one on the first one anyway, so I can just say 2x plus 3, right? Oops, forgot my 3. Sorry, 3. Okay, so then when we go down here, I could put in negative, use the fraction template, but I could also just do this. I could say negative and just put the 1/3 in parentheses. That's a quick and easy way to do fractions on any calculator. You just enclose fractions in parentheses. The calculator will always just treat that like a number, right? Like it's an integer, okay? So in parentheses, I can say 1/3 x minus 4. And then if I just go zoom 6, there's the graph. I happen to see the intersection, which I have to be able to do, and so it's really easy to find it, right? Then I just go second, calculations, 5. And now think about this one. How many times can lines cross? Once. If they're not the same line, they can only cross at most one time, at least in a flat space, in a flat universe, right? We'll talk about some other possibilities
I don't like
later.
when you do that, it confuses me.
Yeah.
Wait,
I don't
why
like
don't
when
we
it
check
uses
out
that.
do second and calc?
Say it again.
Second, so go second and calc.
Exactly.
Second, calc 5.
5.
And then, but here's the part that makes it really easy. Because lines can only intersect once, we don't even need to make a guess. So when you're doing a linear system, if it's lines, you can hit second, calc 5, triple enter. Just enter, enter, no guess needed, it'll instantly find the answer because they're lines. It's easy. Okay? And so the answer is -3, -3. Okay? Now, another quick point I'll make is this. A lot of times we go zoom standard because it gives us a nice kind of conventional, familiar setting, right? -10 to 10, both directions. And if we're dealing with, as we're going to find, when we're dealing with other kinds of functions, things that aren't just lines, like parabolas later on, when we get to chapter 5 and we start doing quadratic functions, parabolas can start to look really strange if you make the window really big. Parabolas can start to look like, instead of looking normal, they can get real shrunken in one dimension, and so you can't just be real blasé about making the window huge when you're looking for solutions, intersections of parabolas. But with lines look the same on any scale, don't they?
Yeah.
They're just lines. They're just straight and long, right? So it doesn't matter what scale you put this thing on. You can make the window as big as you want to without any fear of doing any kind of weird thing to the graph. So if you don't see the line, you don't see the intersection right away, if it's off the screen, I wouldn't fart around with making like -20 to 20. Just make it -100 to +100 on both axes and just find it. Then you're not going to have any issues about. Does that make sense?
Short answer,
Okay.
-3
All right.
far around.
Okay, good. Please don't. Yeah. Yes.
Can you show what happens if you just get the parentheses around the fraction?
Well, it's, okay, a lot of times it'll work, but a lot of times it won't too. There are some instances where either it should work and it doesn't, the technology doesn't work. Some calculators won't actually do order of operations correctly. Or you may think you're doing order of operations correctly and you're actually not. And so it's always a safer bet when you're dealing with fractions to just put them in parentheses. Yes, ma'am?
Will you just click the y equals button again so I can see how you?
Sure. Yep. Okay, and once again, you can use the fraction template on your fancy calculators, and it's great. It just takes an extra keystroke.
Okay, so for when I'm doing like the intersects, and
Okay, listen, please.
when I'm doing the intersects, it asks for like, guess, it asks for the first curve and the second curve.
Right.
Well, sometimes like when I'm pressing the second curve and I press enter, it just stuff goes
To the second, what do you mean?
when like the first curve, I'll press enter on it, and I'll go to the second
Every
line,
one
and
to
the
that.
second curve, I'll press enter,
Mhm.
and then it like.
And then you put the negative outside.
You're right, because you have to, there's three things it needs. First curve, second curve, yes.
Yeah, but then it doesn't ask for guess. Sometimes.
You have to show me that. You have to show me. It must, yeah, something's, yeah. Okay, question.
Then I should put -4 or minus.
You could the negative be inside? Sure.
No, like x.
Oh,
minus-
right here. Could you put plus -4?
No, is it negative? A negative?
Okay, oh, negative won't work.
Minus.
Okay, good. No, a negative is not. Good question. Glad you asked that. So, because everybody runs the risk of doing this. Watch real quick here. So, the question is, could I make that minus sign a negative sign? If I do that, the calculator assumes that I'm multiplying -1/3 x by -4. Because that's our multiplication rule. If I put two things next to each other, it's implied multiplication. Okay? So, negative sign and minus sign, very different. And there are key differences there. You gotta make sure you're using the right one. Okay, so now here's the other issue though. So that's really easy to do, but what if I give you equations in standard form? Okay? Which I'm gonna do, because I just wanna make things difficult for you. And a lot of times we like to write linear systems in standard form. Okay, so what if I do this? Yes. Oh, yeah.
You're like, oh.
Okay, there you go. All right, so here we go. Look and listen. Okay, so what if I give you this one? What if I give you the equation in standard form? Remember how that works? That's ax plus by equals c, where a, b, and c are integers, no fractions. Okay, well, you will. We'll look at this a lot. So it just means things like this. Instead of mx plus b form, slope-intercept form, y equals mx plus b, it'd be like 2x plus 3y equals 7, right? Okay, yeah, okay, good. Or something like, how about down here if we did -4x plus 6y equals 7. Okay? So now the question is, I mean, obviously we can solve that, and analytically we could use probably linear combination to be the easiest, and we'll review that a little bit on Monday. But I mean, you guys will know that stuff. How do we do it in a calculator though? What's the glaring problem? Okay, good. In the calculator, it's expecting the y to be isolated. It says y equals, and y is not by itself there. Okay, this is a fantastic trick, so watch this very closely. This will save you, you're gonna love this one, this is great. This is our trick of solving into the calculator, or isolating right into the calculator. You can literally do the algebra as your input into the calculator. We'll do one, how about with the fancy fraction template and one without, so you can see both ways. Okay, so on this first one, we'll use the fraction template. How about, if I want to isolate y up here, what are the steps I go through to get y by itself? Okay, subtract what? 2x and divide by 3y. Now, divide by 3, right? Would you agree that when I'm done with that then, I'm going to end up with 7 minus 2x on the top of my fraction and the whole thing divided by 3?
Yes.
Okay, so then what we want to do is when we solve for y, we know on the other side we're going to expect to always get a fraction, right? Whatever's already on that side is going to end up, of course, in the numerator. but we're gonna maybe add or subtract something else to that in the numerator, and then divide by the denominator. So we'll just set up a fraction template on the other side if we're using fraction templates. So alpha F1,
Wait a minute, but I'm confused. If you already know like what everything happens, why don't you just write it as 7/3 and 2/3?
you could, but this is easier. You'll see. You watch. You'll answer your own question. This will be easier. It's really because what if those what if those were? It always takes. It's more difficult to look at something as split fractions than as with a common denominator. Okay, and that's why this is easier. So on the top, if we're going to isolate the y, whatever's on the other side, I just start with that. It's already in the numerator. And I don't need this to look fancy. I just need it to be algebraically accurate. So it's okay for me to start with the 7, and then I'm just going to subtract 2x from 7. I don't need to write that as negative 2x plus 7. I mean, I could, but why? They're algebraically equivalent. So I have the 7. I'm going to subtract 2x onto this side, right? And then in the denominator, I'm going to end up with whatever the coefficient of 3 is, right? Because that's what I'm dividing both sides by. So I'll just throw that 3 right into the bottom.
Wait a minute, what if this loops a fraction?
Okay, but if it's in standard form, it never will be. Okay, that's part of the deal about standard form is the coefficients A, B, well at least A and B, well actually none of them can. If it's written correctly in standard form, then A and B and C have to be integers. If it's written incorrectly, which it might be, I mean, you could run into that. If one of those is a fraction, that's okay. It's just a number.
It's a fraction over a fraction.
Yeah, that's fine. That's fine. You can either just put it in parentheses, or you can drop a little second fraction template that's in the top if you want it. If you want to really look fancy. Okay? So there's the first one. And if I graph this thing, I want you to notice that it works. I just did zoom 6. Yeah. So it works. It doesn't need to be solved fancy so it looks like it's in y equals mx plus b form. I can leave it just like that, and the calculator does fine with it. It's pretty smart. It doesn't have to be simplified for the calculator. Okay, so there's one of my lines. For the other one, let's not use the fraction template. Okay, I personally think this is faster. I would do it this way if I were you. So I know that on the other side, yes, Lauren.
So when you say you do this way, you think it's faster, so do the top one that way?
Well,
or is it
I'm
all
saying,
the second
you
way?
can decide. I'm saying I would do it the way, the second one,
Okay.
without having to draw up that fraction template. But the fraction template's nice because you can see what you got very clearly. On this one, now if I solve the second one for y, you tell me what I'm going to get. Y equals
No, 7.
7.
Plus 4. Over 6.
Okay, 7 plus 4x over 6, right? So we know that the numerator starts with a 7. If I'm not using the fraction template, I can just open up a set of parentheses for the whole numerator, right? I always open up a set of parentheses, and I always start with what's already there. So 7 plus 4x, close the parentheses, right?
Close them.
Because I have to divide that whole thing by 6.
But you have to put that in parentheses.
No, you don't have to put the 6, because the 6 is just one thing. You only need parentheses if it's more than one thing together, isn't it?
If we're not really comfortable with this yet, can we just do it like solve it first and then?
Solve it for y first, you mean?
Yeah.
You can, but you're gonna like this so much better because it's gonna be so much easier to do.
Okay, but we can't do the fraction first.
Yeah, sure, you can. But this is just a way quicker way of doing it, and the problem with that is gonna be also when you're doing things like linear inequalities, then, well, it just gets harder to, we're gonna take the same trick and we're gonna push it down to the unit where we talk about systems of linear inequalities also. It works really well there too. And it has the added advantage of it's really easy to keep track of the direction of the inequality sign. So I would urge you to kind of just get comfortable with it if you're not at first, because it's really easy to get comfortable with. So either way you do it, now if I just hit zoom 6, I've got an intersection to go find and it's really easy to do. Okay? Now I'm gonna tweak this, but I gotta do 2 more little tweaks, or you're gonna run into a couple problems where you're gonna wonder, how do I do this with a graphing calculator? So how about this one? I'm gonna change my problem very slightly, Doesn't seem like a lot, probably, but I'm gonna do this. I'm gonna make this sign a negative sign, if I said something right, I think I did. That's gonna make a profound change to things. So it's not gonna change the second equation very much, right? All I'm gonna have there is instead of a 6 on the bottom, it's a negative 6, right?
Yeah.
Everybody agree? So I can just go down and edit that?
Have to put it in parentheses.
Nope. Okay, good question. You don't need to. A negative sign sticks to the number, and you don't need to put it in parentheses. Good question. So a negative 6. And if I go graph, okay. Oh,
What?
okay, so maybe. I mean, what if they were just almost parallel? What would happen then? Okay, so it'd intersect like way up there somewhere or something. Okay, so we could make the window really big, and I'll tell you what, it's always gonna look pretty parallel. So how do you know which one it is though? Oh, look at the slopes, very good. If lines are parallel, what's true of their slopes? They're equal, okay. We could do this analytically, because they're just lines, but we can also use the calculator to do it. If we go second to our bag of tricks on the calculations menu, it's the 6th option. This is our fancy calculus way of saying slope, dy dx. All it means is change in y over change in x. That's slope, right?
Why do they come up with all these new letters for everything?
Well, when we get to calculus, we'll talk all about that, and you'll see. Yeah. Okay, so dy dx, and the reason they're using this is because it'll actually tell you the slopes of curves, even not just lines. And we'll, eventually we'll talk, even this year, talk about that a little bit. So dy dx is slope. So if I choose option 6, okay, from my graphing calculator tricks, right now it's on y1.
Wait.
So second calc 6.
On this
Yep.
one?
Second calc 6. And then the cursor up here is on the top line, and it tells you at the very top that that's y1. So if I hit enter, what it's going to do is it's going to tell me the slope of the top line. It keeps the cursor there to kind of visually show you that, okay? It doesn't matter if I trace along these things, there are lines and the slope's never going to change, right? The line is a property, or slope's property of the line. So I get negative 2/3 for the top one. All I have to do is compare that to the bottom one, right?
I didn't know that. It's like,
And
Well,
so,
we just enter them as that, or do we have to enter them as
no,
that?
you'd want to make it, well, but it didn't even ask what the slope was. It just wanted to know what are the solutions, right? Intersection. And so this one has a slope of negative 2/3. And so if I go second calc 6, and this time I'm going to toggle down. The way you skip between functions is the up and down arrow. So if I hit the down arrow, it goes to y2. And now if I hit enter, it tells me the slope of y2. It's the same thing. So I know that they're parallel, right?
So then would
Because
you
they share the
enter-
same slope.
then would you enter no solution?
No solutions. Exactly, yes.
But that's just double that, so couldn't you have figured that out? Or not?
Yeah, we could have. You're right. You saw that, that's good. You could have probably seen that. And you guys are smart enough that with lines, and once again, with lines, you could power through this stuff analytically, but what if these weren't lines? What if they were logarithmic functions or something where it's harder to see those relationships? Then this is a pretty good tool. Okay, so one last thing. I'm going to tweak this thing one more time. You tell me what's going on here. I'm going to make that a negative 14, how about? Okay, so we'll go up to y equals, and instead of that 7,
Down one.
I'm going to turn that into a negative
That's the same.
14. And if I hit graph, okay, so where to go? Okay, it might be the same line, right? The other possibility would be, and we're pretty sure it is, right? The other possibility would be, what if it were just way off somewhere and we didn't see it, okay? But there's a way we can do a quick test on this to see if it's the same line. And it is just a logical. You guys, this will make sense. If I go to y equals, wouldn't you agree that if I turn off one line at a time and nothing changes, it was the same line? Or you have a color calculator. That's right, the new one. Does it show up as purple? Does it really show up as purple in there?
No, it like way red and then it
Blue,
and
and
then
the
it
red
was
comes
like
down.
Oh, that's cool.
Well, ours can't, ours is black.
Yeah. Okay, so all you have to do to turn the line off, listen. To turn a line off on the graph, you just unhighlight the equal sign. So if I go over to the first one and I unhighlight the equal sign, I'm only graphing y2. Well, it looks the same. So at least we know that was y2. Go back to the y equals menu,
Wait,
turn the
how many
first,
notes highlighted?
watch, see now it's highlighted. Go up, come on buddy. Oh, where'd it go? Okay, so now if I hit enter, see how it highlights it?
Yeah.
So now that one stays highlighted. I'll go down and unhighlight this one,
Okay.
so it's off.
So it'll be black. when it's
Yeah, yeah, yeah. And then if I hit graph, doesn't change. So obviously they're the same line. So how many solutions?
Infinite.
Infinite. Okay, let's go. 205.
Can we see the calculator stuff?
Yes,
Phil,
absolutely.
I'm sorry.
Yeah.
I